I welcome you all to my YouTube channel. So today we are going to discuss a few questions from CSI and Chemical Sciences, uh, June 2019, from part C. So our first question is the correct statements about the metal cluster, given metal cluster from the following given statements is: the first statement is it is an 86 electron cluster. Number B, it is a closure structure type. Number C, its shape is kept square pyramid. Number D, carbon interacts with all the ruthenium centers in the cluster. So, how do we proceed to solve this question? In the question, the first statement given is it is an 86 electron cluster. So, first of all, our job is to count the electrons, that is the total number of electrons for the ruthenium organometallic complex. So the electron count for the complex is, we have 6 ruthenium metal atoms, so 6 into 8 electrons, that is the ruthenium falls in the group of iron, so iron is D6. So ruthenium also has 6 electrons, 6d electrons. So in the neutral atom method, we also count the number of s electrons. So 6 plus 2 is equal to 8 electrons. So plus we have a carbon atom. So carbon belongs to group 14. So carbon, the electron count for carbon is 4 electrons. Again, there are 17 carbonyl ligands surrounding the ruthenium metal atoms. So the electronic contribution of the carbonyl ligand in the neutral atom method is 2 electrons. So 17 into 2 electrons. So 6 8 is 48 plus 4 into, we have 34 electrons. So total number of electrons is 86 electrons. So the first statement that it is an 86 electron cluster is correct. Next we have, the next statement is it is a closure structure type. So in this kind of metal clusters, in order to determine a structure type, first of all we have to count the framework electrons. So the framework electron count is given by the formula total electron count minus 12 into number of metal atom. So the total electron count in this organometallic cluster is 86 electrons. We have 86 electrons minus 12 into number of metal atoms. So we have 6 ruthenium atoms, 6 number of ruthenium metal atoms. So 12 electrons into 6, we will have 72 electrons. So 86 minus 72 will be 14 electrons. So the framework electron count satisfies the 2n plus 2 category. That is, if you see, the number of metal atoms is 6. So n implies the number of metal atoms. So 6 into 2 will be 12 plus 2 will be 14, which satisfies the framework electron count. So since the metal cluster satisfies the 2n plus 2 category, so the structure can be predicted as closure. If we have 2n plus 4, it will be nido, and if we have 2n plus 6, it will be irrational, so on and so forth. So the second statement is also correct. Now the third statement is its shape is kept square pyramid. See, the given cluster adopts an octahedral structure. That is, the ruthenium metal atoms are distributed in the polyhedra of an octahedron. An octahedron has 6 vertices. So the ruthenium metal atoms occupy the 6 vertices of the octahedron. So its structure is octahedral. So the third statement is incorrect. That is, its shape is not kept square pyramid, rather it is octahedral. So the third statement is the carbon interacts with all the ruthenium centers in the clusters. So the carbon is situated in the middle of the octahedron. So the carbon is at the interstitial position of the octahedron, that is, it occupies the center of the octahedron, and as a result it interacts with the ruthenium metal atoms situated at the equatorial position. That is, the 4 ruthenium atoms situated at the equatorial position of the polyhedra interacts with the carbon atom. So the carbon atom only interacts with the 4 ruthenium atoms situated at the 4 vertices of the equatorial position, not the axial position. So carbon interacts with all the ruthenium centers statement is not true. So after verifying all the statement, we come to the conclusion that option 4 is correct. The next question. So we have been given a reaction, a plausible structure of the intermediate involved in the following reaction. So this is a organometallic compound of iron. So we have the one cyclopentadienyl ligand, we have one methyl ligand and 2 carbonyl ligands. So overall this organometallic compound of iron reacts with triphenyl phosphine and gives us this product. So in order for the triphenyl phosphine ligand to react with this organometallic compound, it has to proceed through an intermediate. So in the question we have been asked to identify the intermediate out of the 4 given options. So the given complex is this. So we have the iron metal center, we have a cyclopentadienyl ligand, we have a methyl ligand and 2 carbonyl ligands attached to the metal center. So the total electron count for this organometallic compound is 18. So in order to accommodate the triphenyl phosphine ligand, the alkyl group undergoes migratory insertion. You observe that the methyl group that is attached to the iron center undergoes migratory insertion onto this carbonyl ligand. So when this methyl ligand migrates onto this carbonyl ligand, the resulting complex is a 16 electron complex. So after this organometallic compound has been converted into a 16 electron complex, the triphenyl phosphine ligand can easily come and get attached to this iron center, and the overall electron count for the final product will be an 18 electron complex. So if we see the options, then option 3 is the correct answer. I hope all of you have enjoyed this session. So I hope if you like this video, please share with your friends, and please subscribe to this channel.